Right, in part 2, section 2, we're going to look at displaying and summarizing two categorical variables. In class, we looked at a lot of different graphs. So let me pull up the graph. One graph we looked at in class and one additional graph. So we looked at this graph during our activity over here, and we discussed how many different variables were displayed. So we actually had the gender, we had the race, and then we had the 6-year outcomes given over here. So actually 3 variables displayed. This is a stacked bar chart. So a bar chart is for categorical data. When we compare different groups, we oftentimes use a stacked or a side-by-side bar chart over here. So the nice thing about these is that you're able to compare percentage, and you can really see the differences, like which race and gender had the highest completion rate at the starting institution. You simply look at the height of the bar. So here we have for the Asian women had the highest success rate, followed by the Asian men, and so on. You can also look at who had the worst success rate, and over here we can see that the Black men had the worst success rate, followed by actually the Hispanic men and the Black women over here. One really neat thing about this graph is that in addition to having the percentages up here, we also have the total numbers. So we can see that we have 57,516 Asian men, we have 126,985 Black men, and so on. So not only are we seeing percentages, but we're still seeing the number of people within each group. Most of the times when we look at these stacked bar charts or bar graphs, we only see the percentages. Oftentimes they don't report the number of people within each categories. So this is actually a very cool graph. One other graph I want to look at briefly is up here, the plea offer types for felonies. Very similar. This time we have a side-by-side bar chart over here. One thing you have is that these percentages for each group add up to 100%. Again, it's supposed to show the differences within each group. So we don't necessarily know how many white defendants we looked at and how many Black defendants we looked at, but we can definitely see that there's a difference in the outcomes as far as how many of them were offered jail or prison time versus community service, fine, time served, or others. So going down to the following section over here, when we first look at our data is going to be given to us usually as an Excel spreadsheet where each observational unit is one row. So maybe we have, a person with a number identifying the person. Then we have, the race being identified, like we had the Black versus white. So maybe we have a Black person first, and they're offered, jail time, and so on. Maybe the next person is another Black person, and this time they were let go. Another white person maybe was jail time, and so on. So we're taking that data and we're actually able to put it into a contingency table. So the contingency table allows us to display these two variables, so the race or Black versus white, and the outcome as, one is the row variable, the other one is the column variable. So we call that a contingency table. Sometimes we use contingency tables that have exactly 2 outcomes for each one of our variables, in which case oftentimes you'll see a 2-by-2 table. But oftentimes there's more than 2 outcomes. So a contingency table encompasses all number of categories in each one of those variables. There's a number of statistics that you can calculate. So you can calculate different probabilities or percentages. Sometimes we use the margins of our table, which give us the marginal distribution or marginal percentages. And sometimes we use the inside frequencies. Those are our joint frequencies or joint probabilities. we will do an activity for that this week. We're going to move on to the next activity because I don't have our classroom data available yet for our majors. So please fill out the survey and we'll come back to this. So let's look at the types of contingency tables we can make. We can either look at the joint proportions or relative frequencies. And the joint proportions are, you can find inside your table. So these divide each cell frequency by the total of the entire table. The conditional proportions or conditional frequencies, you condition upon a category first. So maybe we want to check, we want to know, within the white group, what percentage got jail time. And this is exactly what our graph that we looked at, the side-by-side bar chart did. It displayed our conditional proportions or conditional percentages. Make sure you pay attention to what condition you're conditioning by. So make sure you're dividing it by the correct total. Let's look at an exercise over here where it says a survey of autos parked in student and staff lots or at a large university. Classify the brands by country of origin. So we have American cars, we have European cars, we have Asian cars. In addition, we have student or staff drivers. So again, this is a contingency table. We have the type of car or the origin of the car, labeling our rows, and we have the type of driver labeling our columns. We can see that we have a total of 362 drivers. And when we're asked to find what percent of all the cars surveyed were European, we're simply going to take the European total, which is 48. We're going to divide it by the grand total of 362. And then we're going to rewrite that as a decimal, and after that as a percent. This is equal to 0.1326, which is 13.26%. The next question is asking what percent of the American cars were owned by students. So we are particularly interested in the American cars. So I'm going to highlight just the American cars. And we want to know what percent of them were owned by students. So over here, we're looking at the student percentage within that group. So we are conditioning upon the type of car over here. So that's 108 divided by 212. And so let's calculate that. This is equal to 0.5094. or 50.94%. The next question is asking what percent of cars were Asian and owned by a car driver, by a staff driver over here. So our keyword for this one is and. So we want a person who is both. We're going to ask out of all the drivers, what percent were Asian and owned by a staff. So let's highlight first all the Asian ones over here. We're also going to highlight the staff drivers over here. And we want the person to be both. So for a joint frequency, we're actually looking at the frequency that is both. So both Asian and staff, that's 46 out of the grand total of 362. So one thing to notice over here when we're looking for marginal probabilities, like the first question, where we're finding our answers in the margin of our table, we divide our total we're looking for by the grand total. When we're looking for an and probability or a joined probability, we are going to find the one cell that's both, divide by the grand total. The only percentage or probability that we adjust is conditional probabilities, and this is where we have to be very careful whether we're conditioning upon the type of or the origin of the car or the type of driver. So again, the first one is called a marginal distribution or probability or percentage. The second one is called a conditional. And the last one is called a joint. This is equal to 0.1271, which is 12.71%. The last question is asking us to create a conditional contingency table, conditioning on the type of driver. So first of all, what we want is our total for the type of driver to be 100% over here. So we're conditioning on the type of driver, which means we're first going to look at our students, and we're going to look within that category, and then next we're going to look within the staff, and we're going to calculate those percentages for each one of them. So over here we would take 108 divided by 197. We would take the 33 divided by 197, the 56 divided by 197, and those percentages are all going to add up to 100%. Then we do the same thing with the staff. We take 104 and divided by our total of 165 this time for the staff, 15 divided by 165, and then we take the 46 divided by 165. Not sure why my pen isn't working over here. Maybe there's something covered, but I'm going to rewrite this right next to it, and then you'll be able to see the difference. All right, so here we have our conditional table. Again, we have the American, European, Asians labeling the rows. We have student versus staff labeling our columns. I simply divided 108 by 197. I left it as a decimal, but you know, if you ask for percentages, you would simply convert it to a percentage to 54.8%. Within the student drivers, there's 16.8% European cars and 28.4% Asian cars. So those numbers add up to 1, or if we converted it to percentages, that would add up to 100%. We do the same thing with the staff. We take 104 divided by 165. That gives us 0.63 or 63% American cars, 0.91 or 9.1% European cars, and 0.279 or 27.9% Asian cars. Those again add up to 100%.